Here's problem 36. A segment of wire of total length 3 meters carries a 15 amp current and is formed into a semicircle. Determine the magnitude of the magnetic field at the center of the circle along which the wire is placed. Alright, so we're going to form a semicircle of wire, and we want to find the magnitude of the magnetic field at the center point P. And we're told that this total length of this wire is 3 meters long, and if it's carrying a current, that current is equal to 15 amps. As I'm looking at it here, if I were to point my thumb in the direction of that current, then at point P my fingers would be curling into the page, so the magnetic field in this case would be going into the page by the right hand rule. Okay, we want to find this magnetic field, and according to curved segments, that would be equal to mu naught I over 4 pi r times theta, where theta is the angle in radians. In this case, it's going to be pi radians because it's half of a circle, and r is going to be the radius of this circle, which we don't know what that is, but we do know that the length of this semicircle is 3 meters. So we know that a full circle would be 2 pi r, so a semicircle would have a length of 2 pi r divided by 2, and that is going to be equal to our total length L, which is 3 meters. So that means r is going to be equal to 3 meters divided by pi, and what is that? 3 divided by pi. 0.955 meters. So that is the r that we're talking about here. Alright, so if we continue this, mu naught is 4 pi times 10 to the minus 7. The angle theta is going to be pi radians. Oh, and our current as well, don't let me forget that. 15 amps of current over 4 pi, and then we just found our radius of this circle would be 0.955 meters. The 4 pi's cancel out, and what do we get? Let's see. I got 4.93 times 10 to the minus 6 Tesla, and as we've drawn it, it would be into the page, and that is our answer. 4.93 times 10 to the minus 6 Tesla.